This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering. In today's session, we will be learning about the determination of centroid for simple sections. The course outcome of today's session would be identify the centroid and center of gravity for the simple and composite plane sections from the first principles. The topic covered would be determination of centroid for simple sections. And the topic learning outcome is understand the concept of centroid and center of gravity involved in practical engineering problems. Let us first try to understand what the centroid is. We have already discussed about the centroid, which says that it is the point through which the total area of the section is concentrated. That means the area, whatever area that the lamina is having, the two-dimensional figure is having, the total area would be concentrated at a single point, and that single point is treated as the centroid. And for identifying this centroid, different orientations or different plane laminas will have the position of the centroid differently, right? So for identifying that centroid, the formula which we can apply or formula which we can use for identifying the centroid will be different. So each and every plane lamina, like rectangle, square, or a triangle, trapezoid, whatever it may be, the different orientations or different plane sections laminas will have the different centroids. So we will be identifying the centroid using the first principles, nothing but the system, the basic procedure we will be using for identifying the centroid of plane sections. First, let us find the centroid of a rectangular lamina, and the procedure for identifying the centroid for all the laminas is same. So we will be considering this example of rectangle, for which the rectangle we are going to identify the centroid. So this is the figure given. Consider a strip of thickness dy and a width b at a distance y from the base x-axis as shown in figure. So as we have discussed, there must be reference axis for each and every object which we are going to identify for calculating the centroid or center of gravity, right? So here what we are considering the reference axis as x-axis at the bottom of the object and y-axis at the left side of the object here, right? So these two are the axes. This is the x-axis and this is the y-axis which we are going to consider as the reference axis. Now for this rectangle, we are considering a small strip here, a small strip of thickness dy, and which is lying at a distance of y from the x-axis, that is base axis. Okay, so the size of the rectangle which we are considering here is the height of the rectangle is h and the width of the rectangle is b. Okay, so for this kind of rectangle which is shown in figure A, we are going to calculate the centroid or identify the centroid. So area of this particular strip which we are considering, can be written as dA, that is dA, which is equal to the area of rectangle. This strip is also a small rectangle, right? So the rectangle which is having a height of dy and the width of b. So the area would be b into dy, that is length into breadth of the rectangle. And the area of rectangle A, so the complete area, when we are considering this total area of the rectangle, what we will do is we will summate this type of strips like this. We will be dividing all the rectangle into number of strips, and we are going to summate all the rectangles so that we will be identifying the total area of the given lamina. So the total area of rectangle is treated as A is equal to integral 0 to h. Starting point is origin, right? The level of this base is at 0 to all together, all the way along to the height of h. So this strip's area making summation as starting from 0 to the total height h. That will give the area of the total lamina. So this area of rectangle, total rectangle, can be obtained as area A is equal to integral 0 to h b into dy. And the position of the centroid from base, that is x-axis, can be obtained as y bar is equal to integral 0 to h, that is area, right? Area into the distance of the centroid that we have already considered, right? So the area, complete total area of this thing is integral 0 to h into dA, and y is the distance, okay, and by the area of the rectangle, which is the formula of the centroid, okay. So we are applying this formula of the centroid for identifying the distance of the centroid from the x-axis. So the equation can be written as integral 0 to h y into dA by a. So that gives integral 0 to h y into b into d into y, which we have identified previously. That the area of the strip dA is taken as b into d into y by a. So that can be written as b, when we evaluate this integration, that will be obtained as bh square by 2 by bh. So when you simplify this, you will be obtaining h by 2. So this h by 2 is the area distance of the centroid from the x-axis, nothing but at exactly the center, exactly at the center of the lamina or the rectangle, okay. So this is what the procedure to identify the centroid's distance using the first principle. Similarly, if the position of the centroid from y-axis is considered, right? So what would be the representation here? The y-axis is present here, and the distance of the centroid from the y-axis would be x bar, right? It is x bar. So the position of the centroid from y-axis, that is x bar, can be derived considering the strip of thickness dx, okay. Now for identifying the centroid's distance from y-axis, what we are doing? We are considering a strip vertically. Previously, we have considered the strip horizontally, and we have identified the distance of the centroid from the x-axis. Now we are going to identify the centroid using the vertical strip, and the procedure is same. And the dx is at a distance x from the y-axis. So from that we can obtain the value of x bar as b by 2. So that would be again exactly at the center, and the value would be x b by 2. So this is the centroid's position. So in as we have seen here, we have obtained the x bar and y bar's position as b by 2 and h by 2. The coordinates has been identified like this. Okay, so this would be your formula for identifying the centroid for a given rectangle. Anytime a rectangle is given, directly you can apply the formula, that is at the position of the center of the object, the center of the lamina, the centroid will be applied. So the centroids of plane geometrical shapes, if we consider the same procedure will be used, we will be identifying a small strip, and we will be taking the area of that small strip, and then we are going to apply the integration for obtaining the area of the whole lamina, and then we will be identifying the position by substituting this into centroid's formula, right? So the same procedure will be used for identifying all the centroids for all the plane sections. Directly how the values of the centroids will be given here, we can see as the examples. First one is we are the square, centroid of the square, it would be the area of the square would be b square, and the position of centroid would be b by 2 and b by 2. Okay, so here the size of the square is taken as b, length and breadth as b. So the position of the centroid would be y bar from x-axis and x bar from y-axis. So when we consider this, the value of centroid, the position of the centroid would be b by 2 and b by 2. Similarly, for rectangle, just now we have identified area would be bd, and the distance of centroid from x bar, that is distance of centroid from y-axis would be b by 2, and the x-axis would be d by 2. Okay, where the size of the rectangle considered is d and b here. Similarly, for triangle, the size of the triangle is considered as height h and base b. Okay, height h and base b. For this type of triangle, the triangle having a height of h and base as b, we are going to consider the areas as bh by 2, and the centroid's distance would be b by 3. B by 3, that is base by 3 from y-axis, and h by 3 that is h by 3, the height by 3 from the x-axis. So these are the coordinates of the centroids for the triangle. Then when we consider the shape of circle here, having a diameter d, okay, having a diameter d, the area of the circle would be pi r square, where pi is the radius of the circle, and d by 2 is at the center, right? The diameter by 2 and the diameter by 2 would be the coordinates of the centroid for the circle which is considered. Similarly, the semicircle, having a diameter of d and radius of r, semicircle, the position of the centroid, the area would be pi r square by 2, and the position of the centroid from y-axis. The y-axis we are considering at the end here. Okay, you do remember we compulsorily need to consider the reference axis anytime. Okay, when we are considering the y-axis at the edge of the semicircle, the position of x bar, that is x coordinate from the y-axis would be d by 2, that is given as r, whereas from base, which is considered as x-axis, the position would be y bar is yr 4r by 3 pi, 4r by 3 pi. So all these calculations will be obtained by using the first principles, right? Then coming to a quadrant having radius r, and the centroid which is positioned here, the area would be pi r square by 4, and the position of the centroid for this particular quadrant with respect to the axis, here we are considering the axis as base and from the side. Okay, so for this type of situation, the x bar, which is the distance of centroid from y-axis, is 4r by 3 pi, and y bar, which is the distance of centroid from x-axis, is 4r by 3 pi. So in this way, we are taking the centroid's position and centroid's values. Coming to parabola, as shown here, the area of the parabola would be 2 by 3 into AB, and x bar and y bar values are 3a by 5 and 3b by 5. And circular sector having radius r, and the reference axis are considered like this, x and y. For this, the area would be r square into alpha, and the x coordinate of the centroid would be 2 by 3 r sine alpha by alpha. And the y bar here shown is 0 because wherever the position is considered, the x bar is being considered, it is at the centroid's position, right? The x axis which is being considered here, it is passing through the centroid of the object, so there is no distance of centroid from the x axis. That's the reason y bar is considered as the 0 value. So this concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.